Alright, let's solve a question from continued proportion. So you'll see that there are some questions of this type in the previous year's board papers and specimen papers. Now, anytime we have this sort of a question where A, B, C are in continued proportion and we have to prove something, there are usually two different methods that we can use. In this question, I will solve it using both the methods. Let's say the first method is that if A, B and C are in continued proportion, we know that given A by B is equal to B by C. This is the meaning. If I cross multiply, I'll get B square equal to AC. Now, wherever I see B square, I'll replace it as AC. So in the LHS, which is the more complicated side, I will replace this B square and this B square with AC. But I also have a single B over here and over here. So if B square is AC, B will be square root of AC. I will replace that over here. So let's say that the LHS is now equal to, after if I do these two substitutions, LHS is equal to 3A square plus 5 into A into, now B is root AC, so A into root AC plus 7B square, B square is AC, divided by 3B square, so B square is AC, so 3AC plus 5 into, now B is root AC multiplied by C plus 7C square, nothing to change for C square. Now if I look at the numerator, I see that A is common in all the three terms, so I can take A as a common factor. So A multiplied by 3A plus 5 into root AC plus 7C divided by, now if I look at the denominator, C is common in all the three terms, so I can take C as a common factor. Then I will get again 3A plus 5 root AC plus 7C. So luckily these two expressions in the numerator and denominator are equal and I can cancel both of them. So this will be equal to A by C, which was the RHS. So this is equal to RHS, hence proved. So this is one solution, one method. Another method is called the K method. So let's look at that. And K method is suitable for some questions. Maybe for this question, we already have this method which is possible. So maybe we can prefer this and for this question. But let's still look at what is K method. In K method, let's say that A, B, C are in continued proportion. So it is given that A by B equals to B by C. And let's say that both these ratios are equal to a constant K. Then A by B is equal to K, B by C is also equal to K. So A is equal to BK and B is equal to CK. Now since B is equal to CK, this B that I have here, I will substitute as CK. So I will get A equals to CK into K, which will give A is equal to CK square. So wherever I have A, I will replace with CK square. Wherever I have B, I will replace with CK and C will remain as C. So in the LHS, I will do the substitutions like this. So LHS will be equal to, now I have 3A square. A is same as CK square. So LHS is 3 CK square whole square. You have to do this very carefully. Then the second term is plus 5AB. A is CK square and B is CK plus 7B square. So 7 CK square. This is the numerator divided by the denominator 3B square. So 3 CK square plus 5 B into C. I will replace B as CK, but C is remaining C. We are not changing it. Plus 7C square. Again, C we are not changing, so it's 7C square. So this took some time to write, but if you do this carefully, you'll get it correctly. Then we just need to expand whatever can be expanded, and then we'll take common factors. So 3 ck whole square is c square k to the power 4 plus 5 into c square k cube. K square into k is k cube plus 7 c square k square divided by 3c square k square plus 5c square k plus 7c square. Okay, now if I look at the numerator and denominator, from numerator c square is there in all the terms, and maximum I can take k square also as common. Then what remains is 3k square plus 5k plus 7. And from the denominator also I see that c square is common but not k. We don't have k in the last term, so c square is common. Then what remains is 3k square plus 5k plus 7. And again, luckily we have this common expression in numerator and denominator. We can cancel both of them. Also, c square can be cancelled from numerator and denominator. So the LHS is equal to k square. The LHS is equal to k square. Now in k method, I also have to look at what is the RHS in terms of k. RHS was a by c, and a was ck square, and c I will not substitute anything. So if I look at it, RHS is also equal to k square. So I will say that therefore LHS equals to RHS. Hence proved.